Good morning, afternoon, or evening, whenever you're watching this. Today we're going to be talking about normal distributions. It's an application of both mean and standard deviation on a data set, and so you will see how that works together. You'll be using normal distribution to be able to come up with percentages, and this will come in handy, especially those of you that are potentially going into business, because stats is one of those topics. Please keep in mind that we are looking probably sometime towards the tail end of next week to be going into an assessment, and we also have a Math Excel, so let's get rolling straight away here. First off, vocab. Don't get terribly upset, but most of your common statistics, or many of them at least, such as your height, your weight, or your blood pressure, are gathered from samples in the natural world, and they tend to have what is called a normal distribution. Okay, there's a preponderance of large numbers of people in the middle and fewer people on the ends. It tends to look very bell-shaped. That's why we call that the symmetric bell-shaped centered curve. Now, as a high school student, the thing that's probably more significant to you are there are two lovely tests that your life is riding on. It's called the ACT and the SAT. Those are also going to be normally distributed tests because the average score tends to be the one that is in the middle. Okay, most people get that. And you end up getting roughly the same number of people getting 36s on the ACT as you end up getting single digits. So let's see what we can do. And I would say right now, if I was in your shoes, I would immediately stop this and just copy this box down because we're going to be using it. Now, unfortunately, it's a completely not quite complete thing, so I'm going to add in two more things here. Down here, that's 0.15%, and up here, that is 0.15%. So please take a second, stop the recording, and copy this down so you can work on things. Give it a second. Okay, let's discuss this little graph and see what we can come up with. Oh yeah, and I'm going to add my 0.15% here and my 0.15% there. Okay, first off, it's going to have its maximum number at the center, which is pretty self-explanatory, and the graph will be symmetric around this center value, which is the mean. But it's not just the mean, it's the mean, median, and mode. They're all going to be that center thing. Now, the percentages you have there are something that is called the empirical rule. And what we can do is we can use this to try and find values. For example, I know that going from one standard deviation to the left of the mean to one standard deviation to the right of the mean, that's going to get me a grand total of 68%. Then if I add an additional standard deviation, which means from 2 standard deviations to the left to 2 standard deviations to the right, you're going to end up with 95%. And above and beyond, the 3 standard deviations is going to get me 99.7%, which is why over here we've got this and that, which ends up being 0.3%. Okay, let's move on. So if I'm going to do this, and we'll do a basic problem here. If a normal distribution has a mean of 50, okay, normal distribution, nice bell-shaped curve, has a mean of 50. That means in the middle, it's 50. And my standard deviation of values is 11. So I'm going to say one standard deviation would get me to 61, and one standard deviation to the other side is going to be 39. Remember, what are those values that I had you copy down? Well, that was 34% on this side and 34% on this side. Last time I checked, those two end up being my 68%. So therefore, I can say that 68% of the values are going to fall between 39 and 61. Okay, let's go ahead and talk real briefly about skewed data. Now remember, normal distribution, I have the same amount on the left and on the right for all of these. However, when you have some outliers, remember your outliers are your values that are way, way bigger or way, way smaller. Okay, when you've got a handful of those, remember it pulls the mean in that direction. So therefore, this pulls it in the positive direction, so it's positively skewed. But these super low values, they're going to pull the mean in that direction. So we say it's negatively skewed. But in general, remember, we want to be working with our normally distributed graphs. Okay, next, let's take a look at this here. Okay, go ahead and sketch this and copy down the mean and the standard deviation, and we'll fill it in. Okay, let's fill this stuff in here. First off, it says that I need to fill in for 1, 2, and 3 standard deviations. I know my mean is in the middle. 1 standard deviation away is 5 away. That's going to get me up to 50, 55, and 60. This is going to be 40, 35, and 30. So now I've got my mean, 1 standard deviation on either side, 2 standard deviations on either side. Now see what you can do with your calculator and see what you can do about finding this value in here. Go ahead and pause this and fill it in and see if you get the right answers. Okay, go ahead and check your work. I'm hoping that everybody did really well. And let's move on to the next thing. There's going to be when we're applying our percentages a little bit better. So it says, I've got my data that has a mean of 50 and standard deviation of 8. So I can right away immediately start filling stuff in. 50, standard deviation of 8 is going to get me values like this. And going down by 8 is going to get me down to there. Now, I also need to fill in my percentages and say in here is 34%, 34%. I'm going to be looking at 13.5% and 13.5%. I also am going to have 2.35% there, 2.35% there, and again remember my 0.15% in there and my 0.15% in here. All right, so what is my percentage running from 42 to 58? So I'm just talking that much in there. That's pretty basic. Don't worry about it. I'm hoping everybody said 34 and 34 is going to get me 68%. Awesome. Next, let's see what we can do on the next one then. I can say that we'll be looking at, since this is, going to be 68%, greater than 34. So I'm looking at this stuff here. Now, a couple ways to do this. Number one, you could say that it's going to be everything except that, which in this case would mean it's going to be 100% minus 0.15 minus 2.35%, which is going to get you 97.5%. Or you can choose to say, no, you know what I'm going to do? I'm just going to add up all of these percentages in here, which turns out, it's going to be a little bit time consuming. But if I just took them and I said, yep, going to add them all up, guess what I ended up coming up with? The same 97.5. And the last way that might be a slight bit easier is that right here is halfway. This is always going to be 50%. And all I need to do is I need to add these two in here and say, I'm going to say that that's going to be 50% plus 13.5% plus 34%. But it really doesn't matter which way you do it, because guess what? You still come up with the same answer. And if you need to replay that and look at it a couple different ways, that's fine also. And finally, less than 50, that's the gimme question of the day. How much is going to be less than 50? Well, what's my percentage? Remember, that's my mean and my median and my mode. It's going to have to be 50%. Okay, moving on. Next. Okay, heights of adult American males. You've got that information. Go ahead and pause and see if you can come up with a normal distribution, filling things in, based off the information that I've given you up here at the top. Okay, and I've filled in the pertinent information for this first question. What percentage of adult males are between 67 inches and 74.5 inches tall? Well, I'm just going to add these three up, and I'm hoping that everybody comes up with 81.5%. Next thing I would like you to do is we can do the same sort of figure, but we need to come up with slightly better questions here. It says, in a group of 2,000 adult males, about how many of them would I expect to be taller than 6 feet? Okay, fill in the rest of the chart as you need to, and let's see if we can come about solving this. And I'll pause. Once again, I'm getting rid of anything that's not pertinent. So I'm going to say that if you are freakishly tall like I am, and you're going to say greater than 72 inches, that's just going to be the sum of the 13.5%, the 2.5%, and the 0.15%, which gives you 16%. But notice it says how many, not what percentage, how many. So I need to take my 16% and I need to multiply it by the total number of people in the group. So I'm going to say 16% of 2,000, or 0.16 times 2,000. That should get me 320 people. Okay, next one. Next, we have the scores on the final exam are approximately normally distributed with a mean of 150 and a standard deviation of 5. I want to know what percentage of students took the test scored above a 180. Please fill that in. Okay, the students that scored greater than 180 is just going to be the sum of what I've got there, and I'm hoping that you guys add these up and you get 2.5%. Let's look at the second question, which is saying, okay, if there are 250 students that took the exam, about how many scored above 135? Let's pause it again and see if we can do the calculation. Okay, so here's my 135 sitting here, and I'm going to say that that's going to be 34%, one standard deviation away from the mean, plus, remember, when I go mean to the right, that's going to be 50%, so I'm looking at a grand total of 84% of the students. But again, I'm looking at how many, not what percentage. So I'm going to take 84% of my 250, which is going to get me, when I pop that in the calculator, 0.84 times 250, that's looking at a value of 210. Okay, same question. If 13.6% of the students received a B on the final, how can you describe the scores? Okay, what scores do B's lie between? Okay, go ahead and fill in your percentages and see if you can figure out where it is. Okay. This is not my favorite question, but I'm hoping that 13.6 looks an awful lot like you to the 13.5, so I'm going to say anybody that got between a 165 and a 180 are probably the ones that got the B's. Okay, last one I want to talk about is this one. It's one where you're given the data and you have to approximate where we're going. So it says, what percentage of men are 69 to 71 inches tall? Well, I'm hoping that people are saying, okay, it's pretty clear I'm looking at this stuff in here. But the problem is I don't have actual values. I'm now going to fill in some approximate values here. I'm estimating using the chart classification there, so I'm just going to say 13, 16, and 14. So it's going to be roughly, you may have chosen different values, 43%. And finally it asked, what percentage of men are less than 70 inches tall? Okay, so what I'm going to do is I'm going to go and fill in everything that is less than 70 inches tall. And I filled in my approximation of the values there, and I add those up and I get roughly 39%. Now on those, I would have to have a certain amount of leeway, but at this point, I'm going to call it quits and say, dig into the Math Excel, folks. Good luck to you, and talk to you next week.